Hi friends, in our last session we have completed with our chapter that was Artificial Intelligence and Data Analytics for Manufacturing. In today's session we are going to start with our new chapter, that is Architectural Design Patterns for CMS and IIoT, that is for Cyber Manufacturing System and Industrial Internet of Things. This is Fazan Kagdi and I welcome you all to our lecture series of Industrial Internet of Things. So let's begin with our first topic. So the first topic which we need to see is CPS based manufacturing and industries 4. So what is the role of industry 4 and a cyber physical system in manufacturing process? So first of all we need to understand that whenever we are going to produce some product or whenever we are going to apply CPS in a manufacturing industry, we need to provide each and every physical entity with a virtual representation. Remember, we need to provide a virtual representation or a digital representation of a physical object. Now, the physical object or entity could be anything. It could be a sensor, it could be an actuator, it could be a product. Okay, so we would say that how we can do that. So for that, it requires a memory. It requires a storage system. It requires a database, right? So that database is called a digital object memory. Okay. Now, digital object memory also is called a semantic object memory. Now, what is a semantic object memory? Semantic means to follow a definite structure. Okay, that is to follow a definite syntax. For example, we can say taking a simple example that I love the flowers, right? I love flowers. Now, it has a proper format, it has a proper expression, right? I love flowers. Now we cannot write it as I flowers love. Okay, which means a proper expression, a structure has to be formed. So that structure which is formed in a database is called a semantic. So semantic object memory, which means every data will be in a proper syntax, will be in a proper structure, will be in a proper manner. Okay, so now these memories that would be stored can be used anytime, can be retrieved anytime for producing any type of a product according to the customer's requirement. Okay, so these products as well as the production line components themselves contains all the production relevant data. Okay, now we can say that in a smart production lines, a centralized orchestration service coordinates the need of each goods and trigger the necessary actuators. Which means remember there are two important things. First is an application or a system that is called a centralized orchestration services. Okay, so this services is basically an application. Now that application is going to coordinate with a semantic object memory or a digital object memory. Okay, now how it is going to coordinate? So whatever need is coming to produce a good, so it is written clearly that the need of each good will be provided to that orchestration service unit. Okay, and that service unit will coordinate with the digital object memory and retrieve all the necessary data related to that object and will trigger the necessary actuators. So we can say that for producing each type of a object or a product, an individual production plan will be created by this orchestration service, okay, service unit, based on a object memory which is in a database and external requirements and a condition. So this concept is going to help to replace the actuators without actually stopping the production line, and all the collected data will be available in a objects and in a production line memory which can be further displayed or processed. Now in order to understand that, we are going to consider certain use cases. So these use cases will describe a metal process workshop in which workpieces are manufactured according to the instructions which are provided by the customers. Very simple. Okay, now a central application that I have told that the central application is a service orchestration. Okay, this application will receive all the data from a customer, and entire data of a workshop will be present, and that will coordinate with the digital object memory. Now what is present in a digital object memory? So within a digital object memory we have all the virtual representations of a physical entity which I have told, right? So that can be easily retrieved. Virtual representation of a actuator, of a workpiece, right? So these are represented digitally by a semantic object memory. Now the question comes at what is the benefit of doing this? So we can say that in this type of a cyber physical production system, which will be enriched with a semantic object memory and a service orchestration, can be processed automatically in variable of a batch sizes, which means without any delay, additional expenses or any other adjustments. So the first benefit foremost, there will be no delay, automatic processing will take place, additional expenses will be cut down, right? And even quality management can be obtained, as well as maintenance planning can be easily done by using this orchestration services and a digital memory. Okay, now let us move further and see the next slide. Now, further, now as it is told that it will have a 4 different stages. So let us consider that the first stage is the arrival of a workpiece. Okay, arrival of a workpiece is the first stage. In a second stage, we can say a data collection will take place or a processing of a workpiece will take place. Then third stage, let us consider it is a stage in which various operations will be performed on a workpiece, such as a drilling operation. Okay, and a fourth stage, let us consider is a milling operation, which means a milling floor will be our fourth stage, on in which a workpiece is going to proceed. Okay, so it is clearly written that upon the arrival of a workpiece, first of all it is scanned for the properties and the instructions that has to be processed accordingly, which means the 2 stages will be completed over here. First we need to retrieve all the informations from a semantic object memory. Okay, orchestration application will coordinate with that. After receiving all the information and necessary data, the workpiece will pass into a third stage, in a next stage. Then we would say it is going to enter into a drilling floor. Now drilling floor with a collection of a different drilling machines, as well as in a milling floor with a corresponding collections of a milling cutter. We know the purpose of a drilling machine is to create a hole in a workpiece, and a purpose of a milling machine is to create a gear, right? We need to cut a gear. So basically the workpiece will be converted into a gear. Okay, now for producing a gear, we know that at a center we need to drill a hole, so that will be done by a drilling machine, and on a periphery of a workpiece we need to cut a teeth, that will be done by the milling machine. So both of which are an optional stages in a workpiece processing. Okay, and the finally finished items are passed on a new destination, that will be outside the workshop. Now the most important thing which we need to remember over here is that service orchestration unit is going to guide the entire process. This entire process of a flow of a workpiece from entry till the exit outside a workshop will be guided by a service orchestration unit, that is an application. Remember, in order to automatically devise the production or to guide a production, what a service orchestration unit will require, what it will need. So it needs a knowledge about a workshop, its capabilities, its properties and a content, but also about a workpiece and the current intended states. Now how this knowledge will be provided to this orchestration unit? So we will say that a knowledge is provided by a semantic object memory, which is going to give a digital representation, which is going to provide a virtual representation of a physical entity, that is our components and a materials within a production line. So remember, these two are the most important parameters: service orchestration unit and a semantic object memories, without which we cannot achieve a production or a manufacturing by making use of a cyber physical system. Remember, now next is an object memory. So in order to understand that, we are going to consider that what will be present in a database, what will be there in a object memories, that we need to see. So first case we are going to consider of a workpiece, that what data of a workpiece will be stored in a database, that is in a semantic object memory. And second, we are going to consider a case in which what data of a machine or a drill tool or a drilling tool or a milling tool will be stored in a semantic object memory. So let us first understand that what data will be stored about a workpiece in a object memory. So as you can see on your screen, that for each arriving workpiece an object memory is retrieved. Okay, specifying its qualities for orchestration unit. Now the memory, now we would say what the memory is going to contain. So the memory is going to contain information about its physical state, such as its size, material and shape, as well as the processing instructions, quality checks result and a current production history. So to understand this, there is a figure which is going to show the composition of such memory, okay, in detail. So let us understand that. First is a production instructions that will be present in a memory database. So these production instructions are the collection of operations to be performed on a workpiece, to be performed on an object. So parameters to these operations and optional sequential order will be provided in a database, that is in a digital object memory. So let us see that production instructions would be like what. So in the next slide, you can see that a figure is shown example for a possible workpiece memory content. First, you can see the instruction. So it is clearly written that an instruction is given drill up to a certain location. So 2311, 1963, 17, 16 you can see. So these are the coordinates, that in which coordinate we need to drill. We need to take our drilling tool to perform a drilling operations, right? So these are the instructions which will be stored in our digital object memory. Remember, x y z coordinate is provided over here, so this is the memory, remember. Then after, what comes in an instruction? Then quality check. What are the parameters of a quality check? Okay, so these all comes under instruction. Now second is, you can see priority. Now what is a priority? So this is again stored in a database. These are the process or a sequence which will be present in a memory, remember, for the workpiece, for the object which has to be machined. So now the what is a priority? So let us say that our priority is that the process should be completed as fast as possible, which means the priority is a speed. It should be performed with a good speed in order to complete as early as possible. Next is the shape. So what is the shape of a workpiece? So that will be instructed. Then hardness. So what is the hardness of a material of a workpiece? That is Brinell hardness. You know, the unit of hardness would be either a Rockwell or a Brinell, right? So the hardness of a material will also be defined, predefined. Okay, so and so for so and so material, either for aluminium, for a mild steel. Okay, then after quality check, so it is going to automatically check whether the quality is as per the pre-required or not, predefined quality or not. So if it is as per the requirement, so it will instruct that it is okay. And then after comes a state. State means whether the workpiece is ready or not, it is finished or not. Okay, so you can clearly see it is written that in a priority, it represents the entry might be used to steer a workpiece path to the production line following a specific requirements, for example fast production or energy efficiency. This is the priority. Then after shape, so the shape is basically an object's dimension which are relevant for choosing a correctly sized machine as well as interpreting the given working instructions. Now what is hardness? As I discussed that some tools are restricted in the capacities concerning specially hard materials and can be damaged if forced to work on a harder object. So workpiece hardness has to be specified. So if a hardness is higher, with respect to that workpiece, we need to change the tool, right? Tungsten carbide tool, right? So different types of tools are available. Diamond tip tool. So these tools can be utilized based on a hardness of a workpiece and can be modified. Okay, now next is a quality check. So you can see it is written diagnostic informations about a workpiece progress after one or more instructions have been executed. And a state. So this parameter is used by the service orchestration to determine the next production step in conjunction with the instruction. Okay, let's move and see the next example. That would be an example for a possible metal drill memory content. So metal drill memory content, which means a drilling tool memory which is present in a digital object memory. So let us understand this. So first column you can clearly see is of a function, second is of a properties, third is of a maintenance, and fourth is a state. Now function is basically what? So it represents that what is a function of drilling tool. So it is going to drill, right? It is going to create a hole. So for creating a hole, what instructions should be given to a drilling tool? So it has to be given which position we have to place the tool, right? Before commencement of a cut. So the position, exact position has to be predefined. So it is written drill x y. Okay, x y means the position, the axis. Then after depth, so up to how much depth we need to create a hole. Okay, and next is the diameter. That means that of how much diameter the hole has to be created inside a workpiece. What should be the diameter of a hole? So this is a predefined which will be in a function of a digital object memory. Okay, so you can clearly see that a digital representation of a different available machines follow a common memory model and fill it with the specific informations in a agreed on format. So now what a function represents? So it is written that ontology based description of a function this device is able to perform. Ontology means that one type of philosophy or one type of a procedure which has to be followed. Okay, step by step. So that is an ontology. Now next is the properties. Properties includes what? So you can clearly see in the table that it represents the size, okay, about a drill size and a retainer size, and second, what is the maximum hardness of a cutting tool. Okay, so these minimum and maximum sizes shapes and degrees of hardness the device is able to process. That is a property which will be present in a digital object memory. Also, it will contain energy consumption per operation, that how much energy will be consumed depending, for example, on a currently equipped tool head. Next, you can see maintenance information. So maintenance information includes a running for how much time. Okay, that is a timing will be given, head size is how much. So regularly updated information about device runtime, tool head attribution, or other relevant influences will be present in a digital object memory, which can be accessed easily. Okay, and next is a state. Now what does state represent? So this parameter is used by service orchestration to determine a device to which an object is sent, which means that which cutting tool has to be used for a particular type of an object. Okay, so that will be defined in a state. Okay, state of a cutting tool which has to be used. Okay guys, so in today's session we are keeping up till here. We will continue with this topic in our next session. So till then, stay tuned and thank you all.